Hello, I am Jennifer Hermes Nastu, Content Director for Environment and Energy Leader, and I want to thank our viewers for joining us today for today's E&E Leaders Live webinar. The webinar today is sponsored by Eastman, and I am excited to introduce our speaker. Today, we're welcoming Chris Layton, Sustainability Director for Eastman's Specialty Plastics Business Unit Group. Hi, Chris. How are you? Welcome.
Good afternoon. Thanks, Jennifer, and excited to be here, share a little bit about what we're doing.
Yeah, thanks. I'm excited to have you, and I know our viewers are excited to hear what you have to say. So today we'll get started in just a minute, but first I wanted to thank everyone who's joining us live and to extend a large thank you in advance to those of us who will be watching us on demand later on down the road, and we appreciate everyone joining us. So before we jump into my questions, Chris, I'd love to have you tell us just a bit about your background and your work with Eastman.
Yeah, sure. So as Jennifer mentioned, I'm the Sustainability Director for our plastics business. I've been with Eastman for about 24 years and have had a variety of roles. Started in the environmental health and safety group, moved into technology. Most of my time has been spent in business or commercial leadership roles. In my current role, I work across all the various segments that we play in and basically help those teams bring to market solutions that are enabled by our two molecular recycling technologies. And for those folks that aren't familiar with Eastman, we're about a $9 billion specialty materials company. And I think this year we're 102 years old. We're headquartered here in Northeast Tennessee, but we have a team of about 14,000 people in plants, research centers, and offices throughout the world. We're not a household name, but there's a good chance you use a product containing one of our materials as we sell to customers in more than 100 countries across a wide variety of applications: durable goods, building construction, transportation, and consumables.
Great. Well, you have a lot of experience, and that's a good background for us as we jump into the questions. So today we're talking about some of the key principles that can turn our vision of a future with circular plastics into a reality. And Chris, as we just heard, you have a lot of expertise in the area. Eastman has emerged as a leader in the area. Or in the area of circularity. And I know you've got some great strategies to share. So let's just jump right in. My first question is, we mentioned circularity, but can you tell us what it means to you, what it means to Eastman, and how Eastman is addressing the issue of circularity?
Yeah, sure. So as a specialty materials company, we think of circularity in that context. So, first and foremost, we think about how our materials can help in the design of products to, number one, ensure you reduce the amount of materials and energy used in the production and use of those products. Mm-hmm. Secondly, how might our materials improve the durability of a product so they can be reused again and again and again. And lastly, and this is where we've spent most of our time here the past couple of years of, how can you create an end of life, be able to recycle those materials to essentially keep the scarce resources in the economy. Contrast that to a linear economy where, we extract fossil feeds, things like oil and natural gas. We make stuff, it gets used and then disposed. So really two different ways of thinking about, product design, thinking about materials. Easier said than done, though, for sure. Right. And so maybe by way of background, Jennifer, let me share a little bit. I mentioned recycling and what we're doing. So in fourth quarter of 2019, we launched and began operating two what we call molecular recycling technologies, carbon renewal technology and polyester renewal technology. Between the two, we can recycle a pretty wide variety of waste plastics, and it's allowing us to provide recycled content, more sustainable products across a huge portfolio. Everything from, the Camelback and Nalgene sports bottles that you see, Procter & Gamble shampoo bottles, Estee Lauder, LVMH cosmetics, Stanley Black & Decker power tools, Warby Parker eyeglasses, a wide variety of different applications, a wide variety of ways that we can use. Today, we recycle up to about maybe 15 million pounds of waste plastic. We're in the process of completing a unit here in Kingsport. When it's done, it will be the largest of its type in the world. And that will allow us to recycle about 250 million tons of material. And then earlier this year, we announced a similar project around polyester renewal in France that will take us up to almost 500 million pounds of waste plastic. So we are keeping very busy.
Yeah.
But we're super excited about what we're doing and the potential of these technologies.
So when you talk about how much you're recycling, are you recycling it to put it back into your own products? Are you making it available for other companies? It sounds like you're doing recycling yourself and then using it in products.
That's right. So think of it as material to material. So we're taking these hard to recycle plastics, breaking them down into the basic, molecular building blocks. When you get back to that molecular level, it allows you to purify those building blocks such that they're indistinguishable from the same ones we produce on fossil feeds. And then we feed them into our existing polymer and fiber lines and are able to make a finished product, as I described, across our whole portfolio with really no compromise in safety, quality, and performance.
Got it. Okay, cool. So that's what you mean by molecular recycling.
That's right. And so that's a great question, Jennifer. And there's a lot of confusion on that. You'll hear people mention advanced recycling or chemical recycling. And the simplest way to think of that, those are umbrella terms. There's a bunch of different technologies under that broader bucket of chemical recycling. We refer to our carbon renewal and polyester, as forms of molecular recycling because we think it describes what we're doing. We're taking those waste plastics and through those two technologies, breaking them down into the basic molecular building block. And as I said, that allows us to purify them and then feed them into our existing process. And we're going from, old materials to new materials.
Right. So, okay. So it sounds like the benefit of molecular recycling is that you take hard to recycle plastics that traditional mechanical recycling can't. So does it replace mechanical recycling, or it enables you to recycle a wider variety of materials?
Another great question, and the simplest way to think about these technologies is their complements. Taking a waste plastic and breaking it back down to that building block requires energy. Less energy than if you were making a virgin plastic, but certainly more energy than what's required for traditional mechanical recycling. Okay. And so, the way I usually think about it is if you can meet your safety, quality, performance requirements for an application using mechanical recycling, you should. But mechanical recycling has some limitations, and that's where molecular recycling sort of complements. First and foremost, mechanical recycling requires, constant replenishment of virgin plastic into that stream. Well, molecular recycling can provide that. Secondly, mechanical recycling generates waste, purging out of the reactors, fines. Those are feedstocks that we would like to use. Mm-hmm. And then lastly, and probably most importantly, these molecular recycling technologies have a much wider range of plastics that we can recycle. So do not think of a clear water or soda bottle. Think instead of maybe a colored shampoo bottle, the rigid clamshell packaging that you'll see grapes and berries packaged in your grocery store, mm-hmm. Films, think of carpet, think of textiles, materials today that don't get widely recycled. These technologies have the potential, and actually we're demonstrating that they can be recycled today.
Great, that's exciting. So, but you mentioned that molecular recycling takes more energy. Did I understand that correctly? So can you talk about what the emissions implications are?
Yeah, sure. So a lot of when people think of environmental and social impacts today, a lot of the discussion focuses on greenhouse gas emissions.
Mm-hmm.
And so for our polyester renewal technology, using waste plastic as a feed, we can get to those molecular building blocks with anywhere from 20 to 30% lower greenhouse gas emissions than getting to those same building blocks via fossil feeds. For our carbon renewal, that range can be 20 to 50% lower versus virgin feeds. And those range depend on the type of waste plastic, how far we have to transport it from the source of generation to our plant, and then what pre-processing we need to do to it in order to feed it into our various reactors. Simplest way to think about it is by using waste plastic on the front end of these processes, you've eliminated all the energy and emissions associated with extracting oil or natural gas, refining that into things like naphtha, cracking that naphtha into ethylene and propylene, which are the feedstocks that ultimately make our raw materials. You've eliminated all those steps. And that's why the benefit of eliminating materials that go to landfill as a result of using these technologies is pretty obvious. It's less obvious that sort of greenhouse gas benefit from it, and it's pretty significant. The other, I would say, environmental benefit that we're seeing is that these processes are comparatively pretty high yield. And what I mean by that is, around 90% of what goes into the front end is coming out of the back end of the process as new material that we can in turn keep in. Now, obviously, any process generates waste. One of the advantages of being at a large integrated facility is we have our own capability of handling any wastewater or solid waste generated through those in a safe and appropriate manner. But the processes themselves are pretty high yield.
So 90%, that's a heck of a lot more than I would have guessed.
Yeah, it varies. I mean, in all honesty, it varies a little bit on the type of waste plastic, but in general, what we're trying to source so we have efficient yields, the economics work, and around 90% is about what we're seeing. And we're always looking at, how do you improve that? How do you increase sort of the types of materials that you're able to recycle? So it's been 2 years of almost everyday learning, for sure.
Yeah, I bet.
Continue to learn.
So when you're talking about all the different types of materials that you are recycling, how is it complicated to keep track? Like, is there a system you have to keep track of what's being recycled, how you're using it? Obviously, I'm sure there's a system, but can you address that?
Yeah, sure. So using these technologies at this scale for recycling plastic is new. And so when we started on the journey, we felt it was really important to have some level of transparency. And the way we've chosen to do that is by having our processes audited and certified by an independent third party. We use International Sustainability and Carbon Certification.
Okay.
ISCC is an internationally recognized certification system for sustainable materials. They're headquartered in Europe, and they have certified, I think, more than 4,000 companies across the globe. And for our customers, that certification does two things. First, it allows them to make a claim with meeting. It allows them to put that recycled content where it's valued most, so that they can excite their customers, make their customers feel good about buying materials that are more sustainable. Secondly, it gives them comfort, because they'll know they can make a claim, and there is a transparency, a paper trail through their value chain, if you will, that they know at the start of that process an appropriate amount of waste plastic has been recycled through it. And so that ISCC has been, I think, pretty important from our perspective in maintaining the credibility and the transparency as you feed waste plastics into the front end of these large, essentially chemical facilities that are now, feeding some amount of waste plastic on the front end of the process.
Right. So the companies that are using these products that you're providing, you mentioned Procter and Gamble, Nalgene, how are they using the same, do they need to use the same third party to certify? Like once you've certified it, is there more of a process for that?
Yeah, so each step in that value chain, and it varies depending on application, but generally each step in the value chain, all the way to the brand, has that same certification. So you have that transparency for each handoff in the value chain. Sometimes that's pretty simple. It's us directly to a customer. Sometimes there's one or two converters in between. And so as we've started this process, we've made sure that those value chains have that certification all the way through.
Got it. And then can the products that you create using the recycled materials, can they then be recycled again?
Yes.
I guess that's the whole point of circularity.
That's right. For us, that's about trying to create circularity. And it varies. The ease at which we do that depends a little bit on the material. And so I'll use examples of, like that Procter and Gamble shampoo bottle. Well, that's made of a material called PET, which is pretty widely recycled. And so that's a material that we can close the loop. We can take that old colored shampoo bottle, recycle it to create a new one. Contrast that to more of the products on our durable side, like the Triton copolyester that goes into the Camelback and Nalgene water bottles. That material is recyclable through these technologies. The challenge that we're working through now is how do you establish a collection value chain? So in simplest terms, if you think of the recycling challenge, it's not only the technologies to do the recycling, it's the collection. And so we're working with partners throughout the value chain to try to create that circularity, get things that aren't collected, aren't recycled today through various means to be able to then return. The good thing is that that Triton is durable, and it's 3 to 5 years of usage that you get out of the bottle before you have to worry about the end of life. But we're starting to look at those things now to be able to create an end of life for all the materials, even the ones that are durable.
Right. That was going to be my next question was, do you work with your customers to, how the heck do we gather these at end of life? Like, what are the programs to make that happen?
Absolutely. Probably the best couple examples that we have today are around eyewear and an auto example. So in the manufacture of an eyeglass frame, they generate scrap. Well, we're working with companies like Luxottica, Warby Parker, and others to be able to get that scrap back, recycle it, and then return it to them in product. And that's, again, easier said than done because you have to create the value chain to get it collected. Most of that stuff today just goes to a landfill or incinerator. Right. Another great example is for the past, I'd say maybe a year or so, we have been working with a company called Padnos and a consortium of the US automakers, US AMP, they call themselves, to recycle what's called auto shredder residue. So basically, at the end of the life of a car is disassembled. The metal gets recycled, but then you end up with a lot of plastic and other materials that by and large get landfilled. So working with Padnos and USAM, we're trying to leverage our carbon renewal technology to recycle those materials. Again, real early in the journey on both of those, but we're trying to show the world what's possible, and you start small, but hopefully be able to scale those things.
Right. Yeah, that's really exciting. I love hearing these stories and these projects. It makes me, I think it makes everybody feel a little more hopeful. And, it also just makes good business sense. So we're almost out of time, but do you have any other thoughts that you'd like to share with us before we close? And maybe, I mentioned good business sense. Do you have thoughts on it's not just good environmental management, but how is it for the business?
Very much so. I mean, you can see the fact that as a company, we're willing to invest in these technologies and making big investments, and are happy with kind of the success we've had thus far.
Mm-hmm.
And so, I guess as I think about my environmental energy leader peers, there are a couple things that I would say. First and foremost, these are big, complex challenges,
Mm-hmm.
and they're not going to be solved by any single solution. It'll take multiple. And so I encourage all my peers to, be courageous to take some risk, look for partnerships in different places that you haven't, historically found them. Be persistent, right? Because you'll learn a lot of things work well and a lot of things that don't, and you need to keep persisting. And for us, the success has been really in finding those good partners. The ones that I mentioned earlier, Jennifer, are leaders in their respective spaces. They recognize the value of more sustainable products, and they're trying to do the right thing, and their customers are demanding of that. And they're showing the world what's possible. And so we've been really fortunate of having a good set of partners to work with that has helped our early success here and give us confidence in those future investments that we're making.
Right. Great. Well, it's exciting stuff. I look forward to hearing more about the progress that you guys are making.
Jennifer, thank you. And again, on behalf of the Eastman team, thanks for having us.
Yeah, thank you. And you shared a lot of great information. I know our viewers will be excited. And thanks to our viewers for tuning in. We appreciate it. And we'll see you all for the next edition of Leaders Live. Thanks. Okay.